Hello everyone, welcome to Talent's Virtual ECG Training, TVET. This video focuses on atrioventricular conduction ratio. This is an important aspect of ECG analysis and interpretation, and it is useful in the assessment of atrioventricular block and in the assessment of a few cardiac arrhythmias. I am Oluwadare Ogunlade. At the end of this video, we should be able to understand how to determine conduction ratio. Conduction ratio is an assessment of the degree of conduction of atrial impulses through the atrioventricular node. Normally, every P wave should be followed by KRS complex, so the conduction ratio is 1:1. In the absence of block, every P wave, every atrial impulse should be conducted through atrioventricular node. So that means P wave will be followed by one KRS complex. The P wave will be followed by KRS complex, or KRS complex. A KRS complex will be preceded by P wave, so it's ratio 1:1. So conduction ratio is 1:1. But whenever there is a atrioventricular conduction block, the conduction ratio will not be 1:1. So and it should be determined. So this is identifiable when there is group beating phenomenon or Luciani phenomenon. And a group beating is a situation in which the P waves and KRS complexes occur in clusters. So that is group beating. And when group beating occurs, you determine sequence. The sequence, and a sequence is a cluster of P waves and KRS complex separated by a pulse. Let's look at the panel below. You will see this group of KRS complexes this is a group of KRS complexes and P wave. So separated by this pulse here. This is another group of KRS complexes and P waves separated by another pulse. So this is a group consisting of PKRST, PKRST, then P. Now this is another group, second group. But you determine the sequence. A sequence begins with P wave that is conducted to end with P wave that is not conducted, but it must include it. So it starts with P wave that is conducted to embrace the non-conducted P wave. So the beginning of the sequence is the P wave that is conducted, and the end is the P wave that is non-conducted. Then the cycle picks up again to form another sequence. There is a pause. So, and to determine conduction ratio, having identified group beating, then identify sequence. You count the number of P waves in a sequence to compare with the number of KRS complexes in that sequence. For instance, in the first case, we said that the conduction ratio for this one, conduction ratio is ratio 1:1. That is normal. So for the second panel, so conduction ratio is determined by counting the number of P waves in this sequence. The sequence is indicated by this yellow arrow. So beginning here to end here. Count the number of P waves: 1, 2, 3. So P waves, we have 3 P waves, 3, So we count the KRS complexes in that sequence 1, 2. So the KRS complexes are 2. So conduction ratio for this lower panel is 3, 2. Now look at the second sequence 1, 2, 3. So 3 P waves, 1, 2, then 2 KRS complexes. So conduction ratio is 3, 2. In a strip, conduction ratio may be the same, may be fixed from one group to the other. It may also vary from one group to the other. So let's look at another examples. So this example one here is every P wave is conducted. Every P wave is conducted. So conduction ratio for this, the first panel, conduction ratio will be 1 to 1. Ratio 1 to 1. Let's look at the second panel. For the second panel, this is P wave, KRS T. P, then there's a misbit here. P, KRS T. P. So there's grouping. There's grouping. So let's identify the groups, then determine the sequence. So there's group bits in here. So we identify the group. So the group, it starts from here. So now there's a pause here. So it embraces this. This one group. Now this another group. This another group. Let's determine the sequence. The sequence will begin with the P wave that is conducted to end with the P wave that is not conducted. This is the P wave. So it stops here. So this is the sequence. Now let's look at this one too. So the sequence starts with the P wave that is conducted to the P wave that is not conducted. So start with the P wave here that is conducted to the P wave that is not conducted. So that is the sequence. So let's determine the conduction ratio. You count the number of P waves within this sequence 1, 2. So that is 2 P waves. Then count the number of the KRS complexes, only 1. So that is ratio 2 to 1. Every other bit is not conducted. So that means this 2 P waves, 1 KRS complex. 2 P waves, 1 KRS complex. The same thing. The conduction ratio here is also the same thing. 2 P waves and 1 KRS complex. So ratio 2 to 1. Let's look at the example, other example below. If you look at the third panel, you see this P wave. It's a P on T here. There's a P wave here, then there is a pause. Then the cycle picks up again to end here. So the conduction, there is group bits in here. So let's identify the groups. This is one group. Another group starts from here to end here. So another group starts here. So to end here. I can see 3 groups here. Now let's determine the sequence. The sequence start from this P wave that is conducted to end with this P wave that is not conducted. There are 2 P waves that are not conducted, so it ends with the last P wave that is not conducted. So the same thing here, the same thing here. So let's determine the conduction ratio. So the first thing is to count the number of P wave 1 in this sequence. 1, 2, 3. So 3 P waves. So that is 3 P waves. Then how many KRS complexes in that sequence? So only one KRS complex. So it is 3 to 1 conduction ratio. So conduction ratio here is 3 to 1. Let's look at the last example. If you look at this example now, there is also group beating. So it starts from these P waves and end with this P wave on T that is not conducted. So there is a pause here. There is non-conducted P waves here. So KRS complex is supposed to be here, but it's absent. So let's identify the group. So it's embraced from here. Now there's a pause here. That is one group. Now another one picks up here. So to end here, so I've identified two groups. Let's determine the conduction sequence. The conduction sequence here, so it will start from this P wave that is conducted, now to end with the P wave that is not conducted, and this P wave is on this T. That is the one that is making indentation on this T. Look at this T that doesn't have P wave on it. It's different from this T. So this is TP fusion. There's P here. So the same thing happened here. Now let's determine the conduction ratio. So what you need to do is to count the number of P waves. 1, 2. There's another one here. 3 is buried in the C wave here. 3. So that is number of P waves there. We have 3. So let's count the number of the KRS complex in this sequence. So 1, 2. So this will give us 3 to conduction ratio. So this is how to determine conduction ratio while analyzing ECG strips, and it is very important for analysis of atrioventricular block and also in assessment of cardiac arrhythmia such as atrial flutter. If you have benefited from this video, kindly subscribe to my YouTube channel to get more videos. Thank you.